It begins on a cloudless morning along the coast of California. A sleek rocket stands poised on its launch pad, its silver body gleaming under the rising sun. In the control room, a dozen pairs of eyes are fixed on a wall of monitors. The countdown ticks in calm, mechanical rhythm. Yet beneath the precision, there is tension. A quiet, collective understanding that what's about to happen could determine the future of decades of science. At exactly 10:02 a.m., the engines ignite. A thunderous column of fire lifts the Atlas V into the sky, and with it, a new generation of vision, Landsat 8, humanity's latest eye in orbit. But this is not just another satellite launch. What's at stake is nothing less than a continuity of memory, a 40-year record of our planet's changing face. Landsat is not merely a machine. It's a time capsule, a witness that has watched the Earth evolve from space since 1972. Every flood, every wildfire, every shrinking glacier, recorded pixel by pixel, frame by frame, through the decades. If it fails, the longest continuous photographic record of Earth ever made will be broken. If it succeeds, it will extend a story that began long before the first digital camera. A story that started with astronauts pressing their faces against small round windows in the early 1960s, astonished by the fragile beauty of the world beneath them. This is a story about how we learned to see our own planet, not as a flat map, not as a set of political borders, but as a living, breathing system. It's a story that connects Cold War rivalries to climate science, geology to art, and pixels of light to the survival of entire ecosystems. Over the next few hours, we will travel through time and space, from the first grainy images taken during the Mercury and Gemini missions, to the modern satellites that can trace the retreat of glaciers and the growth of megacities. We'll see how the idea of remote sensing transformed into one of the most powerful tools for understanding Earth's environmental fate. And we'll ask a question that grows more urgent with every passing year. As we continue to change the planet faster than ever before, can we still rely on these eyes above to help us understand what we're doing and what's left to save? The countdown has already reached 0. The rocket is gone, climbing into the blue. Our story begins here with a launch that's not just sending a satellite into space, but a legacy into the future. Part 1. The first images from orbit. It's the early 1960s, and the world is locked in a contest of power, pride, and technology. The space race dominates headlines. Every launch, every orbit, every human minute spent beyond the atmosphere is a point scored in a global rivalry between the United States and the Soviet Union. Amid the frenzy to reach the moon, few notice the quiet revolution unfolding on the way there, the discovery that the greatest unknown world might be our own. The first astronauts who escaped Earth's gravity weren't just explorers. They were eyewitnesses to something no human had seen before. Through the small circular windows of their capsules, they stared down at the swirling clouds, the continents, and the vast oceans that seemed to glow against the blackness of space. Even with the simplest cameras, they began to capture what would become some of the most transformative images in human history. When John Glenn orbited Earth in 1962 during the Mercury program, he carried with him a 35mm camera, a consumer-grade device taped to his glove. The results were crude, blurry, but profound. Scientists back on Earth realized that these images contained information about coastlines, deserts, forests, details that could never be captured from aircraft or the ground. By the time the Gemini missions began in 1965, NASA had learned to take advantage of this new perspective. Astronauts spent days circling the planet, photographing it systematically. The view was astonishing. The green arc of the Nile, the amber folds of the Sahara, the white crest of the Himalayas. But beyond beauty, the pictures hinted at potential, a way to observe the entire surface of Earth objectively, consistently, and without political boundaries. No one understood this potential better than William Pecora, a U.S. geologist who served as the director of the United States Geological Survey, USGS. To Pecora, space wasn't just a frontier, it was an instrument. He envisioned satellites not as military tools, but as scientific lenses that could help humanity monitor its own planet. Its forests, its farms, its water, and the invisible patterns of change shaping them. At the time, it was a radical idea. NASA was focused on putting humans on the moon, not cameras over Kansas. Government administrators feared the costs. Military officials feared the implications, a public satellite that could photograph any country on Earth from orbit. But Pecora persisted, arguing that Earth needed its own space program, one dedicated not to conquest but to understanding. In 1966, his proposal reached the Department of the Interior, a satellite system designed specifically to study the planet's surface. It would use sensors capable of seeing in both visible and infrared light, able to detect the health of crops, the spread of deserts, and the scars of deforestation. The project was named the Earth Resources Technology Satellite, or ERTS, a technical title that barely hinted at the revolution it would start. After years of negotiation and engineering, the first spacecraft was ready. On July 23, 1972, a rocket lifted off from Vandenberg Air Force Base, carrying with it a machine that would soon be renamed Landsat 1. It was a modest satellite by today's standards, a few hundred kilograms of metal and glass, equipped with a pair of scanners and a tape recorder. But what it captured changed science forever. For the first time, humans could see Earth as a single system, forests breathing with the seasons, rivers carrying sediment into the sea, cities expanding in geometric grids. Landsat didn't just photograph the planet. It began to measure it, pixel by pixel, over time. Tragically, William Pecora never saw the launch. He died just days before it left the pad, unaware that his vision had finally taken flight. Yet his legacy endured. Within months, scientists around the world were poring over Landsat's data, discovering patterns and changes invisible to the naked eye. It was the birth of a new discipline, remote sensing, a science that would soon redefine how humanity monitors its environment. And it all began with a few astronauts, a few photographs, and one simple realization. To understand the Earth, sometimes you have to leave it. Part 2, the era of the data dynasty. By the mid-1970s, the faint idea of watching Earth from space had evolved into a global enterprise. What began as a single experimental mission, Landsat 1, had proven itself indispensable. Its images revealed not only what our planet looked like, but how it changed. Scientists had seen vegetation bloom and fade, rivers shift course, and coastlines slowly alter their outlines. For the first time, there was a record of Earth that transcended borders, governments, and even generations. When Landsat 2 lifted off in 1975, it didn't replace its predecessor, it joined it. For several years, both satellites orbited in tandem, overlapping their coverage so that no part of Earth went unseen. This redundancy was deliberate. It ensured that the record would remain unbroken. And with that, the idea of a data dynasty was born, a continuous stream of observation stretching forward through time. Each new mission built upon the last. Landsat 3, 4, and 5 refined the instruments, improved resolution, and increased reliability. But perhaps the most remarkable feature of Landsat wasn't its technology. It was its consistency. Every satellite followed the same orbit, crossing the equator at the same local time, around 10 a.m., and capturing images every 16 days. Over the decades, those passes formed a visual diary of the planet, each frame layered upon the last like pages in a vast geological journal. That continuity gave scientists a unique gift, the ability to see change unfold. Off the coast of Labrador, for example, Landsat's imagery revealed a tiny dot of land, only 50 meters wide, that had never been charted before. It was officially named Landsat Island, a fitting tribute to the spacecraft that discovered it. But more often, Landsat's discoveries weren't about finding new places. They were about seeing familiar places in a new light. Each satellite carried sensors capable of detecting wavelengths far beyond human vision: infrared, near-infrared, shortwave. By translating those invisible signals into colors, scientists could detect vegetation stress, soil moisture, and mineral composition. A patch of rainforest appeared bright red, a barren desert, gray and lifeless. In the Arctic, glacial ice glowed in icy blue. In the Mississippi Delta, Sediment plumes traced ghostly ribbons across the sea. Through these spectral eyes, Earth's complexity came alive. And so did its fragility. By the 1980s, Landsat had chronicled a startling truth. Humans were reshaping the planet. It wasn't just local change, it was planetary transformation. The disappearance of the Aral Sea in Central Asia was among the most shocking. Once the fourth largest lake in the world, it was vanishing before our eyes, its water diverted for irrigation. Landsat's sequence of images captured its demise, a great body of water shrinking into a dry, salt-streaked desert. In the Amazon basin, the same eyes recorded a different kind of loss. Vast tracts of rainforest were being cleared for cattle and crops. In Rondônia, Brazil, Landsat's view revealed a pattern that looked almost deliberate, a fishbone grid of logging roads slicing deep into the jungle. Over the years, those lines multiplied until entire regions of green turned pale brown. By the turn of the millennium, nearly 1/6 of the Amazon had vanished. Elsewhere, the story was growth. In Las Vegas, the desert city expanded like a spreading flame, consuming the arid land around it. Across the world, China's Three Gorges Dam created an entirely new lake, hundreds of kilometers long, visible from orbit as a gleaming scar across the Yangtze River. Through all this, Landsat kept watch, impartial and unblinking. It documented creation and destruction with the same quiet precision. But behind the scenes, trouble was brewing. The cost of maintaining the program had always been high, and political priorities were shifting. By the early 1990s, the US government debated whether the Landsat series should continue at all. When Landsat 6 failed to reach orbit in 1993, it seemed the dynasty might finally be broken. Yet fate and perseverance had other plans. Landsat 5, launched back in 1984 and never intended to last more than 3 years, refused to die. Against all odds, it continued transmitting data for 28 years, setting a record for longevity that no one could have predicted. That persistence kept the Landsat archive alive long enough for Landsat 7 to take flight in 1999, restoring the continuity once more. Still, nothing lasts forever. A decade later, Landsat 7 suffered its own hardware failure, leaving gaps in its vision. Scientists began to worry again. The dynasty was faltering. Unless a new satellite was launched soon, decades of unbroken data could vanish into silence. And so, engineers went back to the drawing board. Out of urgency and necessity came Landsat 8, a spacecraft more sophisticated than any before it, built not just to survive but to preserve an entire scientific legacy. As the 2010s dawned, one question loomed large. Could humanity continue to keep its own history alive? The answer was about to arrive on a February morning in a rocket plume above California. Part 3. The planet revealed. From 700 kilometers above, Earth no longer looks like the divided map we've drawn across its surface. Borders fade. Mountains rise and fall in long shadowed waves. Rivers glow like veins of silver. The planet becomes what it truly is, a single breathing organism. This was the view Landsat delivered, not just pictures, but revelations. Its images taught us that change is not always obvious from the ground. A farmer might see a single bad harvest. Landsat could see an entire region's soil drying over decades. A city planner could track urban growth. Landsat could measure the heat it produced, the haze it emitted, the green space it consumed. For the first time in human history, we could quantify our footprint. To the untrained eye, Landsat images were stunning works of art, surreal mosaics of red, violet, and turquoise. But to scientists, those colors told stories. Infrared light revealed the vitality of vegetation. Near-infrared showed water's invisible depth. With clever algorithms, researchers could distinguish wheat from corn, coral from algae, living forest from burned remains. In Oman, Landsat exposed a hidden contrast. A lush strip of green hugging the coast, nourished by monsoon rains trapped by mountains. To the north, endless beige, the arid desert. This subtle interplay of color was a reminder that life often survives at the edge of extremes. In the Canadian Arctic, The satellite captured ice glaciers streaked across Axel Heiberg Island, glowing blue against a backdrop of golden rock. In the South Pacific, it revealed swirling eddies formed by wind over an isolated island. The patterns were hypnotic, nature's fingerprints, visible only from space. But the beauty often carried a warning. Each year, scientists compared new images with those from years past, and what they found was unsettling. Forests thinned, rivers ran dry, glaciers retreated. The Aral Sea's ghostly outline kept shrinking, while deserts in northern Africa crept ever southward. In the vast data troves returned by Landsat, researchers discovered what no telescope pointed outward could show, that the universe's most dynamic planet was our own. Landsat's orbit was precise, almost poetic. Circling Earth from pole to pole, it traced a path that allowed it to capture every point on the planet every 16 days, always at the same local time, about 10 in the morning. This consistency was its genius. By imaging each location under nearly identical lighting conditions, Landsat built a visual timeline in which each frame could be compared exactly to the last. The result was not just a snapshot, but a motion picture of change unfolding over decades. The implications were immense. In Alaska, Landsat documented the retreat of the Columbia Glacier, one of the most striking pieces of evidence of global warming in action. In the Amazon basin, it revealed the relentless pace of deforestation, a process once invisible to policymakers thousands of kilometers away. And across the industrialized world, it tracked the expansion of cities, the birth of reservoirs, and the scars left by mining and oil extraction. One of the most haunting sequences came from northern Alberta, where Landsat watched enormous swaths of boreal forest vanish into open-pit mines. Seen from orbit, the mines looked like wounds, dark, irregular shapes against the pale green of the wilderness. Each year, they grew larger. Each year, the scars deepened. Yet Landsat's perspective was never one of accusation. It didn't judge. It simply showed. It allowed us to see ourselves clearly, collectively, and without illusion. By the 1990s, Landsat's archive had grown into a planetary memory bank. Governments used it for agriculture, resource management, and disaster response. Scientists used it to track biodiversity and study climate feedbacks. Even artists began using its vivid imagery to reinterpret the meaning of landscape. What had started as a government experiment had become one of the most valuable scientific datasets in human history. Still, as global awareness of climate change intensified, another realization emerged. Without continuity, all this data would lose its power. The meaning of Landsat's imagery came not from a single picture, but from the sequence, the rhythm of time captured across decades. That's why the launch of Landsat 8 in 2013 was more than a technical success. It was a philosophical one. It reaffirmed a promise humanity had made to itself, to keep watching, recording, and remembering. Because once the record is broken, the story cannot be told again. As Landsat 8 began transmitting its first images, scientists were astonished by their clarity. Each frame was a mosaic of precision, showing the curvature of coastlines, the flow of volcanic ash, and the delicate tendrils of coral reefs. Within months, it was sending back over 400 images per day, a new era of observation. In a way, Landsat 8 was both a descendant and a rebirth. It carried the legacy of its predecessors, yet represented the beginning of something new, a bridge between the analog past and the digital future. And as it settled into orbit, silently circling the planet every 99 minutes, it reminded us of a simple truth. We cannot protect what we do not see. Landsat had given humanity eyes not just to witness, but to understand. And in understanding, perhaps a chance to change. Part 4, The Fragile Legacy. For more than 4 decades, the Landsat satellites had become a silent heartbeat of human civilization. Their orbit steady, their transmissions constant, their vision unblinking. Yet by the dawn of the 21st century, that heartbeat had begun to falter. The continuity that made the Landsat archive so powerful was hanging by a thread. The failures of past missions, the loss of Landsat 6, the crippling hardware malfunction on Landsat 7, had exposed a troubling reality. The world's longest-running Earth observation program could vanish with a single malfunction. Inside NASA's Goddard Space Flight Center, engineers knew the stakes. The Landsat archive wasn't just data. It was evidence, a complete visual record of Earth's transformation through time. It captured the shrinking glaciers of Greenland, the flooding of river deltas, the explosion of cities, the creeping advance of deserts. To lose that thread would be to lose history itself. And so, as the new millennium unfolded, the race was on to design a replacement, a satellite that could not only match its predecessors, but preserve their lineage. It took years. Funding cuts, technical delays, and political reshuffling pushed the project to the brink of cancellation more than once. At one point, proposals even surfaced to privatize the program entirely, selling control of Earth's eyes in orbit to private companies. The scientific community pushed back fiercely. Public access to Landsat data, they argued, was sacred. It belonged to everyone, not to shareholders. Their persistence paid off. Slowly, the vision for a new satellite, Landsat 8, took shape. Built jointly by NASA and the U.S. Geological Survey, it would combine state-of-the-art instruments with the reliability of proven designs. It would carry two main sensors: the Operational Land Imager, OLI, capable of capturing light across 9 spectral bands, from deep blue to shortwave infrared, and the Thermal Infrared Sensor, TIRS, which could detect subtle variations in temperature, allowing scientists to monitor everything from drought stress in crops to heat pollution in cities. These instruments would give Landsat 8 a sharper, more nuanced view of Earth than ever before, one that could reveal not only what was changing, but why. Still, even with all the technological ambition, one thing remained painfully uncertain: time. By 2012, only Landsat 7 remained in orbit, limping, half-blind, its scanline corrector broken, leaving gaps in every image. Landsat 5, the stalwart survivor, had finally fallen silent after 28 years of service. If Landsat 8 failed to launch, the chain, unbroken since 1972, would finally snap. The tension reached its peak on February 11, 2013, at Vandenberg Air Force Base. As dawn broke, the Atlas V rocket stood ready. Engineers and scientists, some of whom had devoted their entire careers to this program, sat in quiet expectation. To 10, 9, 8. In that moment, half a century of effort, discovery, and persistence converged. When the engines roared to life and the rocket tore upward into the clear California sky, a cheer erupted, restrained, professional, but laced with awe. Minutes later, confirmation came through. Landsat 8 was in orbit, healthy, and fully operational. For the scientists who had spent years fearing the loss of the archive, it felt like resurrection. Over the next few months, Landsat 8 underwent calibration and testing. When its first images arrived in May, they were breathtaking, vivid, detailed, flawless. The Andes Mountains shimmered in fine color gradation. The rivers of Alaska glowed with sediment swirls. The Sahara revealed patterns of ancient, fossilized waterways invisible to the naked eye. It was official, the legacy was safe. But more than that, it was renewed. Landsat 8 didn't just continue the lineage, it elevated it. With faster data delivery, improved spectral accuracy, and expanded access, it became a new benchmark for open science. For the first time, Landsat imagery was made available freely to the public, triggering a global wave of innovation. Universities, startups, conservation groups, and even individual coders began to explore the planet through these orbital eyes. The effect was immediate. Farmers used Landsat's thermal readings to improve irrigation efficiency. Governments tracked illegal deforestation and mining in near real time. NGOs mapped coral bleaching and urban expansion. It was as if a window had opened wider than ever before, and through it, humanity could see itself more clearly than at any other point in history. Still, there was a quiet unease among scientists. While Landsat 8 had secured the present, it had also revealed how precarious the future remained. Each satellite, no matter how advanced, had a finite life. Each depended on the uncertain budgets and shifting priorities of governments. What would happen, they wondered, when this I-2 went dark? To ensure the dynasty endured, NASA and the USGS began to plan its successor, Landsat 9. But even before it launched, a deeper question was emerging, one that went beyond technology, politics, or funding. What does it mean for a species to observe itself from orbit for half a century and still struggle to change its behavior? The answer lay not only in data, but in perspective. Landsat had given humanity the tools to understand the Earth. Whether we would use that understanding wisely was another matter entirely. The fragile legacy had been preserved, for now, but the eyes above the Earth were only as powerful as the minds willing to look through them. Part 5. The Science of Seeing. When the first Landsat satellites began transmitting their images, they did more than just photograph Earth. They changed the very definition of what it meant to see. To a human eye, the world is painted in just 3 colors of light: red, green, and blue. But to a satellite orbiting hundreds of kilometers above, the palette is vastly broader. Landsat doesn't merely capture light, it dissects it, spreading it across invisible wavelengths that reveal hidden truths about the planet's surface. The operational land imager aboard Landsat 8 can observe 9 distinct spectral bands. Some of these bands pierce through the hazy veil of the atmosphere. Others detect energy reflected by plants, soil, and water. It's a kind of multidimensional vision, one that turns raw radiation into information. In practice, that means Landsat can measure what our eyes cannot. The health of crops, the moisture in soil, the heat of asphalt, the thickness of smoke, even the chemical composition of volcanic ash drifting across oceans. When these readings are combined, they form something extraordinary, a living, quantitative model of the planet. Each pixel becomes a data point, each image a mosaic of measurement. But how does that work? How can light, invisible to us, describe the world so precisely? The answer lies in spectral signatures, the unique way every material reflects and absorbs light. A healthy forest, for example, reflects strongly in the near-infrared range but weakly in the visible red. Dry or diseased vegetation reverses that pattern. Water absorbs most infrared but reflects blue and green. Bare soil has its own unique fingerprint. By comparing these spectral fingerprints, scientists can classify what they're seeing from orbit with remarkable accuracy. With the right algorithms, Landsat can map global forest cover, estimate crop yields, or trace the spread of algal blooms across oceans, all without ever leaving space. To refine these measurements, the second key instrument aboard Landsat 8, the Thermal Infrared Sensor, TIRS, measures emitted heat rather than reflected light. It captures the faint glow radiating from the Earth's surface, giving each image an added dimension of temperature. That temperature data is crucial. It allows scientists to monitor urban heat islands, where cities trap warmth through concrete and asphalt. It reveals drought patterns by spotting heat anomalies across parched farmlands. It even helps track glacier melting, as rising temperatures shift the delicate balance between ice and water. Together, these instruments allow Landsat to observe processes that would otherwise remain invisible, the subtle breathing of the planet. This is what makes Landsat so unique among Earth observation satellites. While others, like NASA's Terra or the European Sentinel series, specialize in certain measurements, Landsat's mission has always been comprehensive. It's designed not to focus on one phenomenon, but to connect them all, to show how forests affect rivers, how cities alter local climates, and how every human action ripples outward into the biosphere. Over decades, this consistency of observation has created something irreplaceable, a continuous, standardized archive that scientists can use to track change not just from year to year, but from generation to generation. For example, by comparing Landsat data from 1972 to the present, researchers have quantified the retreat of mountain glaciers in Alaska, the collapse of wetlands in the Mississippi Delta, and the spread of megacities across Asia. They've measured how the Arctic tundra is greening as temperatures rise, how the Great Barrier Reef is whitening under stress, and how rivers like the Nile and Amazon shift their channels with every passing decade. Each of these stories is told not in words, but in pixels, each a silent testimony of change. But the real power of Landsat's vision lies not in what it sees, but in how it has changed the way we see. The idea that data could be both art and evidence, that beauty could reveal truth, reshaped not only environmental science, but our collective understanding of Earth itself. When the Landsat archive was opened freely to the public in 2008, something remarkable happened. Thousands of researchers, artists, and ordinary citizens began to download the images, remix them, and reinterpret them. Photographs of deforestation in Brazil became environmental art exhibits. False color images of rivers and volcanoes became posters, teaching tools, and even album covers. The science of seeing had transcended the lab, becoming a cultural force. In this way, Landsat bridged the gap between data and emotion. It reminded us that numbers alone cannot inspire change, but vision can. Each Landsat image, no matter how technical, carries a quiet, humbling message. This is your home, and it's changing. The scientists who first dreamed of studying Earth from space could hardly have imagined how prophetic their idea would become. In an age when climate change defines the century, Landsat's silent gaze is more essential than ever, because to see the planet as a whole is not only an act of observation, it is an act of awareness. And awareness, perhaps, is the first step towards survival. Part 6, The Planet in Crisis. By the time Landsat 8 began sending its stream of crystal-clear images back to Earth, one truth had become undeniable. The planet it observed was changing faster than any in recorded history. The signs were everywhere. In the shimmering white of the Arctic, glaciers fractured like glass under invisible pressure. Across the Amazon basin, the forest, once a dense green ocean, was thinning at its edges. River deltas shifted shape, coastlines eroded, and new islands rose in places where none had been before. Humanity had become a geological force, reshaping the surface of the world in real time. And Landsat had seen it all. When scientists compiled its imagery into time-lapse sequences, decade by decade, pixel by pixel, the patterns were unmistakable. What looked static in a single frame revealed itself as movement. The Earth was alive, but its pulse was irregular. In Central Asia, the fate of the Aral Sea stood as a grim warning. Once the fourth largest lake on Earth, it had sustained entire fishing communities. But by the 1980s, water from its two main rivers was diverted to irrigate cotton fields. From space, Landsat watched the sea shrink like a drying wound, leaving behind salt flats where boats rusted in the sand. What had taken millennia to form vanished in half a century. In Greenland and Antarctica, the story unfolded in slow motion yet with terrifying precision. Landsat's thermal sensors measured the loss of ice sheets meter by meter, revealing melt zones creeping farther inland each summer. The images told a story of acceleration, of feedback loops amplifying themselves. As glaciers melted, they exposed darker rock and soil, which absorbed more sunlight and hastened the melt. The data didn't lie. Between 1979 and 2020, the Arctic lost nearly half its summer sea ice. In Southeast Asia, Landsat recorded the spread of cities like luminous cells dividing across dark terrain. Roads and industrial zones extended into wetlands and mangroves, ecosystems that had once buffered coasts from storms. In China, entire lakes and reservoirs appeared where none had existed before, carved by massive dam projects visible even from orbit. One of them, the Three Gorges Dam, was so immense that its construction displaced more than 1 million people. Landsat's eyes captured the before and after. A river valley transformed into a mirror of steel-gray water. Elsewhere, in the American West, the program chronicled the relentless expansion of Las Vegas, a metropolis blooming in the middle of the desert. Between 1972 and 2010, its footprint quadrupled, spreading across the pale sands of Nevada like a living organism searching for sustenance. The same images revealed the sharp decline of Lake Mead, its bathtub rings marking the depletion of the Colorado River. Across all these cases, one theme emerged, a pattern of imbalance. The planet was no longer merely changing. It was being driven. Scientists began using Landsat data to model the global carbon cycle, to estimate how much carbon forests stored and how much they released when burned. The numbers were sobering. Between 2001 and 2020, tropical deforestation emitted an estimated 5 billion tons of CO2 per year, nearly a tenth of humanity's total output. Yet it wasn't all destruction. The same satellites revealed moments of recovery. Forests regrowing on abandoned farmland in Europe, wetlands returning in Bangladesh after restoration projects, coral reefs showing resilience in remote Pacific atolls. Landsat proved that change, though dangerous, was not always irreversible. But the larger picture remained unsettling. The satellite's long-term perspective offered no comfort, only clarity. While governments argued over emission targets, the data quietly accumulated, frame by frame, bearing witness to what was really happening. Each pixel of every Landsat image contained both beauty and warning. The glowing deltas of the Mississippi showed not just the creativity of nature, but also the fragility of coastal systems threatened by rising seas. The neon sprawl of night-lit cities hinted at human progress, but also at a deepening dependency on the resources fueling it. The irony was hard to miss. The very technology that allowed us to see the planet's distress was part of the civilization causing it. As researchers compared Landsat records with data from other satellites, NASA's Terra and Aqua, Europe's Sentinel, and Japan's ALOS, a unified picture began to emerge. Earth's systems were interconnected in ways no one had fully grasped before. Forest loss in the Amazon altered rainfall patterns as far away as West Africa. The retreat of Himalayan glaciers affected the water supply of nearly 2 billion people. Dust storms from the Sahara fertilized the Amazon basin. Landsat's legacy had evolved beyond imagery. It had become a framework, a planetary feedback system connecting climate, ecology, and humanity. But even as the evidence grew impossible to ignore, there remained a troubling question. Was seeing enough? For decades, the satellites had shown us the damage, forest by forest, glacier by glacier, yet the world continued to burn and build and consume. The cameras could document the crisis, but they could not solve it. In the end, Landsat's greatest revelation was not about the planet's fragility, but about ours. We had the ability to see everything, and still we struggled to change. Part 7. The global watchers. By the time Landsat 8 had settled into its precise sun-synchronous orbit, humanity was no longer alone in watching the Earth. What had begun as a single American experiment had evolved into a planetary collaboration, a constellation of eyes circling the world, each one designed to look at a different layer of the same living system. The modern era of Earth observation is not defined by one satellite or one nation, but by an intricate web of missions from NASA, the European Space Agency, the Canadian Space Agency, the Japanese Aerospace Exploration Agency, and dozens more. Together, they form an invisible architecture that now encircles our planet, collecting more data every day than all previous generations of scientists combined. At its heart, though, the Landsat program remains the foundation. Other satellites specialize in weather, oceans, or atmosphere, but Landsat provides the baseline, the common reference frame against which all others are calibrated. From this collaboration emerged something remarkable, a global observatory. Consider NASA's Terra and Aqua satellites. Launched in 1999 and 2002 respectively, they were equipped with instruments capable of analyzing aerosols, radiation, temperature, and chlorophyll, the subtle forces that drive the planet's energy balance. When Terra measured smoke from wildfires in Australia, Landsat's imagery showed the aftermath. The blackened forests, the scarred earth, the first hints of regrowth. When Aqua detected heat anomalies in the Pacific, Landsat traced the bleaching of coral reefs thousands of kilometers away. In Canada, the RadarSat program added another dimension. Unlike Landsat, which relies on sunlight, RadarSat uses radar waves, allowing it to see through clouds and darkness. Its images revealed the texture of ice, the slow drift of glaciers, and even the subtle rise and fall of the ground as permafrost thawed. Combined with Landsat data, Radar imagery transformed how scientists mapped regions that were once perpetually hidden: the poles, the tropics, the monsoon zones. Across the Atlantic, the European Sentinel satellites, part of the Copernicus program, expanded the view even further. Sentinel-2 mirrored Landsat's optical capabilities but added faster revisit times, while Sentinel-1's radar vision complemented Landsat's optical clarity. Together, they produced a near-continuous stream of data, an unprecedented global record of change updated almost daily. What had begun as a technological competition during the Cold War had evolved into a collaboration across nations and across generations. But this cooperation also brought new challenges. Data flowed from dozens of satellites in dozens of formats. To make sense of it all, scientists had to build a digital Earth, massive cloud-based archives capable of storing petabytes of information and turning them into maps, models, and predictions. This gave rise to platforms like Google Earth Engine, which opened the Landsat archive to anyone with an internet connection. Suddenly, the power to observe the planet was no longer limited to governments or universities. Farmers in Kenya could monitor crop stress from their phones. Students in Argentina could watch glaciers retreat in Patagonia. Environmental activists could trace illegal logging in real time. The democratization of data marked a turning point, a recognition that Earth observation is no longer about secrecy, but survival. And yet, as this web of watchers expanded, so did the responsibility. With so much data, the question was no longer can we see the problem, but can we act fast enough to change it? Every day, satellites detect thousands of environmental signals: methane leaks, deforestation fronts, wildfire outbreaks, collapsing ice shelves. Automated systems now alert governments within hours. In theory, this global awareness could make the world safer and more sustainable. In practice, it depends on political will. Sometimes the watchers can only watch. In 2020, as fires raged across the Amazon, Landsat sensors recorded towering plumes of smoke, visible from orbit like ink spreading in water. Despite international outrage and clear evidence of illegal burning, the destruction continued. Landsat saw it. Terra measured the heat. Aqua tracked the carbon. Yet, on the ground, policy lagged behind vision. Still, the network endured. Even as climate change accelerated, so did humanity's determination to understand it. When one satellite faltered, another took its place. When data gaps appeared, algorithms filled them. This collective resilience mirrored that of the Earth itself, damaged but not defeated. Through these global watchers, we've learned that Earth systems are intertwined in ways once unimaginable. Dust storms in the Sahara fertilize the Amazon. Forest loss in Indonesia changes rainfall in Australia. Melting ice in Greenland raises seas that threaten islands in the Pacific. Each part of the planet echoes into another, and while the satellites orbit in silence, their message grows louder. The planet is one system. There are no separate worlds. From a handful of grainy images in the 1960s to a digital tapestry of the entire globe, humanity has achieved something extraordinary: the ability to see itself from outside itself. But this achievement comes with a question as profound as the view it offers. Now that we can see everything, what excuse do we have for ignorance? The watchers are in place. The data is there. The story of Earth is unfolding in real time, written not in ink, but in light. Part 8. The human equation for all its precision. The story of Landsat is not only about machines orbiting in silence. It's about people, the scientists, engineers, analysts, and dreamers who devoted their lives to turning light into knowledge. Behind every image, every line of code, and every mission milestone, there is a human heartbeat and a conviction that understanding our world is worth the effort, the risk, and the patience. At NASA's Goddard Space Flight Center, there are engineers who have spent entire careers maintaining a single satellite's link to Earth. Some of them remember the early days of analog tapes, when data arrived as faint magnetic patterns on film reels that had to be hand-processed and interpreted. Others belong to a new generation, digital natives who analyze petabytes of cloud-hosted imagery on high-speed servers, searching for patterns invisible to the human eye. Together, They form an unbroken chain of human curiosity stretching back more than half a century. Dr. Barbara Ryan, who oversaw the U.S. Geological Survey's data systems in the early 2000s, once described the Landsat archive as Earth's family album, but she also fought for a radical idea to make that family album public. In 2008, after decades of restricted access and high fees, the USGS made the entire Landsat archive free to download. The decision transformed global science almost overnight. Within a year, the number of users exploded from hundreds to hundreds of thousands. Researchers in developing nations, long locked out by cost barriers, suddenly had access to 4 decades of environmental history. It was one of the most democratizing acts in the history of science, and it didn't come from a lab or a corporation, but from a decision rooted in human values, that the truth about our planet belongs to everyone. The results were immediate and profound. Ecologists began using Landsat to track the spread of invasive species. Economists used it to measure the growth of cities. Archaeologists used it to uncover ancient trade routes buried beneath desert sands. Even humanitarian organizations began to rely on satellite data to deliver aid, mapping flood zones, refugee camps, and areas of drought before sending in supplies. This is the human equation of remote sensing. The idea that data, when shared freely, can empower not only governments but individuals. And yet, as much as Landsat has united scientists and citizens, it has also revealed the limits of our collective will. Seeing is one thing, acting is another. Every Landsat image of deforestation represents not only trees lost, but choices made, political, economic, cultural. Every frame showing a melting glacier is also a mirror reflecting human consumption, human hesitation, and human hope. In this way, the program's great success is tinged with melancholy. Landsat does not blink. It does not judge. It records faithfully, even when what it sees is irreversible. When an ancient forest disappears, Landsat captures the moment without bias. When new growth begins to return years later, it records that too. It is the most impartial storyteller we have, and perhaps the most tragic. Dr. Jeff Masick, one of Landsat's lead scientists, once said, "The data doesn't just show change, it shows consequence. From the rise of carbon-intensive agriculture to the urban sprawl that chokes water systems, the consequences are visible from orbit." The same spectral bands that can track chlorophyll in a rainforest can also measure the thermal footprint of a growing city. And that duality, life and loss, defines the human dimension of the Landsat story. But for every warning Landsat delivers, it also offers tools for resilience. Farmers can now use satellite imagery to reduce waste, planting only where the soil is moist enough to sustain crops. Conservationists can monitor wildlife corridors, ensuring ecosystems remain connected. Disaster response teams can identify landslide zones or wildfire scars within hours of an event. It's a feedback loop between planet and people. The more we see, the more we understand. The more we understand, the better our chances to adapt. Yet, even among the optimism, there lingers a quiet question, a moral one. If we have the data, if we can see the damage, what responsibility do we carry for what happens next? In the end, the greatest variable in all of Landsat's equations isn't spectral or thermal. It's human behavior. The satellites can measure deforestation, but not greed. They can map drought, but not denial. They can reveal the collapse of glaciers, but not the collapse of will. Still, the legacy of Landsat proves that knowledge, even when painful, is power. It gives humanity the chance, however fleeting, to course correct. In every glowing pixel, in every image of Earth turning slowly beneath the sun, there is a silent reminder. We are both the observer and the observed. The question is whether we'll learn from the view, or simply admire it as the world below continues to change. Part 9. The Expanding Mirror. By the second decade of the 21st century, Earth observation had evolved into something beyond its creator's wildest expectations. Landsat was no longer a solitary eye gazing down from orbit. It had become part of a vast, interconnected system of perception, a mirror held up to the planet from every possible angle. But this mirror didn't just reflect the planet as it was. It reflected the planet as it became. Each new image, each new dataset, added another layer to an ever-deepening portrait of Earth, one so comprehensive that, for the first time in human history, we could visualize the world's transformation in real time. In this sense, Landsat had created more than an archive. It had created a planetary consciousness. The raw data that once took months to process could now be accessed in minutes. Artificial intelligence, cloud computing, and machine learning had turned the vast Landsat database into a living, responsive organism, one capable of detecting, comparing, and predicting change. Algorithms trained on decades of imagery could identify illegal deforestation within days, estimate carbon emissions from agricultural fires, or forecast the risk of crop failure before a single seed sprouted. The planet had become measurable, and in that measurement, profoundly humanized. Every year, researchers stitched Landsat's decades of images into cinematic sequences, deserts creeping across continents, rivers wandering like serpents through time, cities blooming in spirals of light. These time-lapses were more than scientific tools. They were emotional triggers, revelations that could move audiences as deeply as any poem or painting. For many, the first time they truly understood climate change wasn't by reading a report, but by watching a Landsat video of glaciers retreating in Alaska or forests vanishing in Borneo. The satellite had become both a witness and a storyteller, a mirror showing us not only the world outside, but the consequences of our choices within it. And that mirror kept expanding. Beyond Earth, probes now circled Mars, Europa, and Titan, sending back echoes of familiar patterns: riverbeds, dunes, deltas. The same instruments used to read the spectral signatures of our planet were being used to study other worlds. The irony was exquisite. The technology designed to understand Earth had become humanity's best hope of finding another one. Yet the reflection it cast was sobering. The more we searched the cosmos, the clearer it became that there is no second Earth. In a laboratory at the Jet Propulsion Laboratory in Pasadena, researchers compared Landsat's images of the Atacama Desert to data from Mars rovers. They found eerie similarities in texture and mineral composition, and yet one difference stood out above all. On Earth, life persisted. Even in the driest, most desolate corners, there was movement, color, respiration. On Mars, only silence. It was as though the Earth itself was holding up a mirror to the void, whispering, "Look closely. You won't find me again." This awareness began to reshape not just science, but philosophy, art, and politics. The overview effect, once experienced only by astronauts, became accessible to millions through Landsat's imagery. People who had never left their hometowns could suddenly see the planet as a unified whole, its patterns flowing seamlessly from desert to forest to sea. Borders evaporated, differences blurred. For a fleeting moment, everyone shared the same vantage point. Governments, too, began to use this expanded mirror in new ways. Treaties on carbon emissions, fisheries, and deforestation increasingly depended on satellite verification. Nations could no longer hide environmental damage behind closed borders. Landsat's impartial "I saw everything." Transparency had become a form of accountability. But transparency is a double-edged sword. While open data empowered citizens and scientists, it also exposed the planet's wounds with merciless clarity. There was no pretending anymore that a dying reef or a vanishing glacier was an isolated tragedy. From orbit, all of it was connected, the feedback loops of a living system straining against imbalance. And yet, for all its warnings, the Landsat legacy carried a strange beauty. To look at the planet through its sensors was to glimpse both the fragility of life and the elegance of its design. A planet that, against astronomical odds, had balanced oceans, weather, and chemistry in a narrow band of habitability. This was the expanding mirror that Landsat had built, a reflection not only of our world, but of ourselves, our ambition, our mistakes, our endurance. In the words of a NASA scientist who once described Landsat as a memory made of light, the archive was more than data. It was a diary of a civilization trying to understand its place in the cosmos. The mirror kept widening, showing not just the changes we feared, but the possibilities we still had left. And somewhere between the clouds and the stars, the Earth, blue, fragile, and astonishing, continued to turn, unaware that it was being studied, admired, and mourned all at once. Part 10. Echoes across time. Every orbit of a Landsat satellite is an act of repetition. The same path, the same altitude, the same local time. But within that sameness lies an extraordinary difference. Every pass records a planet that is subtly, sometimes imperceptibly, changed. It's a rhythm of observation that has continued for more than 50 years. A single satellite sees the Earth every 16 days. The program as a whole has seen it for half a century. Each pass is a heartbeat, each image a note in an ever-lengthening symphony of transformation. Through these echoes, moments frozen in light, we can trace not only the history of landscapes, but the memory of humanity itself. In the Landsat archive, the deserts of North Africa whisper stories of ancient lakes long vanished. The Mississippi Delta tells of storms that reshaped its shorelines. The Himalayas, viewed decade after decade, reveal their slow, shimmering retreat, ice receding like an exhalation. The Earth, as captured by Landsat, is both storyteller and subject, writing its own biography in sediment, forest, and flame. Scientists call this long-term continuity time series data, but to anyone who spends years studying it, it feels more like a living chronicle, a visual record of the Anthropocene. One of the most haunting sequences comes from the Columbia Glacier in Alaska. When Landsat 1 first photographed it in 1972, it stretched in an unbroken mass of ice across the fjord. By 2020, the glacier had retreated more than 20 kilometers inland. Watching the time-lapse feels like watching time itself speed up, a white river of ice collapsing year by year into the sea. But not all the echoes are elegies. Some are symphonies of resilience. In the early 1980s, images of the Cuyahoga River Basin in Ohio showed a landscape scarred by decades of pollution. The river had once caught fire, a symbol of industrial excess. By the 2000s, Landsat images revealed something astonishing. The green returning. Forests thickened, waterways brightened. It was proof that change could run both ways, that recovery was possible if humans chose it. Landsat's long memory makes such comparisons possible. Because every satellite in the program has been designed to capture data in compatible spectral bands, images from 1972 can be directly compared to those from today. That consistency, painstakingly maintained through calibration and engineering discipline, turns the archive into a time machine. But these echoes carry more than scientific value. They are cultural records. When artists and historians began exploring the Landsat database, they found unexpected stories. The geometric beauty of crop circles in Saudi Arabia, the glowing veins of rivers through the Congo, the changing geometry of human architecture. What had begun as a project to monitor resources had become an evolving portrait of civilization itself. Cities, from space, look like constellations inverted, light shining upward instead of downward. From orbit, the human presence appears as geometry. Perfect squares of agriculture in the American Midwest, sprawling fractals of concrete in Beijing and Mumbai, spirals of roads radiating from the centers of old European towns. Landsat captured all of it, sometimes without knowing the significance of what it saw. It was, in a way, human archaeology in real time. These visual echoes became evidence not only of environmental change, but of cultural evolution. They showed the migration of populations, the growth of infrastructure, and the scars of war. After conflicts in the Balkans, in Syria, and in Iraq, Landsat imagery was used to measure the damage, to see what could not be reported from the ground. The same tools that watched the slow bloom of forests could also bear witness to destruction. As the archive grew, so too did the sense that the program was recording something far larger than environmental data. It was recording humanity's relationship with time. For the first time, the human story was not written only in books or ruins, but in wavelengths of light reflected from the Earth's surface. It was an autobiography written by reflection, objective, unedited, and impossible to deny. When researchers replay these decades of data, they describe a strange sensation, the awareness that they are seeing not only the past but the momentum of the future. In each fading glacier, each shifting coastline, there is a projection, a shadow cast forward. And perhaps that is the quiet power of Landsat's legacy, to remind us that history is not static. It's alive, orbiting with us, waiting to be interpreted. The echoes continue to arrive, 16 days apart, year after year. They tell us what we've done. They whisper what we might yet do. And if we listen closely enough, between the wavelengths and the years, we can almost hear the planet breathing slow, deep, and uncertain. Part 11. The politics of vision. The Landsat satellites may orbit far above the clouds, but their view has always been entangled with the world below, a world of politics, policy, and power. Because to see, in the truest sense, is to possess knowledge. And knowledge, on this scale, is influence. When the first Landsat satellite was launched in 1972, the concept of sharing global imagery freely was radical, even dangerous. At the height of the Cold War, a satellite that could photograph any country's terrain raised questions about sovereignty and surveillance. Many governments viewed it with suspicion. Why should the United States have the power to look into another nation's forests, fields, or rivers without permission? NASA and the U.S. Geological Survey countered that Landsat's purpose was not military, but humanitarian, an instrument of science, not espionage. Over time, as the images proved useful for mapping resources, monitoring droughts, and responding to disasters, the suspicion began to fade. Gradually, Landsat's data became the cornerstone of global environmental diplomacy. But that uneasy balance between openness and control never truly disappeared. In the 1980s, as the Reagan administration pursued privatization, Landsat briefly shifted from a public science program to a commercial enterprise. Data became expensive, controlled by private vendors who charged thousands of dollars per image. The result was disastrous. Access plummeted, and scientists around the world lost their ability to study long-term change. Environmental monitoring stalled. It was only in the early 1990s, after public outcry and a shift in policy, that the program was returned to government stewardship. The lesson was clear: Earth observation must remain a public good. Still, the politics of vision persisted. Each new satellite demanded funding, and funding meant justification. Administrators had to argue not just for scientific value but for strategic relevance. Crop forecasting, disaster relief, land management, and climate monitoring. Every few years, the continuation of the Landsat series hung in the balance, dependent on shifting political winds. By the early 2000s, as climate change became a defining issue, Landsat's data gained renewed importance. Its long-term record provided the empirical foundation for international agreements such as the Kyoto Protocol and later the Paris Climate Accord. The ability to verify national emissions and land use changes from space made promises measurable and accountability possible. But this same transparency that empowered cooperation also provoked resistance. Some governments objected to foreign satellites revealing their deforestation rates or tracking illegal mining. The data was neutral, but its implications were not. A single Landsat image could embarrass a nation, expose a lie, or challenge an official narrative. Even within the United States, political tension occasionally flared. Budgets were cut, missions delayed, priorities questioned. To some policymakers, satellites were luxuries. To scientists, they were lifelines. The struggle between short-term economics and long-term understanding has haunted the program since its inception. And yet, despite every political storm, the Landsat legacy endured, in part because it transcended ideology. Whether viewed from Washington, Beijing, or Nairobi, the images were the same. The rivers and forests did not care about borders. The melting ice was apolitical. The truth was visible to anyone willing to look. As the 21st century progressed, new actors entered the scene. Private space companies. Firms like Planet Labs, Maxar, and Black Sky began launching fleets of small satellites, capturing high-resolution imagery at unprecedented frequency. Their pictures could show cars on highways, ships at sea, even construction projects in progress. For the first time, commercial satellites rivaled and sometimes surpassed the capabilities of national programs. This shift introduced a new kind of politics, not between nations, but between public and private vision. Would the future of Earth observation belong to open science or to corporate interests? Would the next generation of planetary data be shared freely or sold as a subscription? NASA and the USGS responded by doubling down on Landsat's founding principle, free and open access for all. In 2008, they released the full Landsat archive to the world without charge. Overnight, decades of imagery became available to anyone with an internet connection. The impact was revolutionary. Academic research exploded, environmental transparency increased, and even small nations could monitor their land without relying on foreign permissions. It was, in many ways, a democratization of vision, a reaffirmation that the right to see the planet is a right that belongs to everyone. But vision, no matter how open, is never neutral. The images can expose, empower, and inspire, but they can also overwhelm. They confront us with scale, of loss, of beauty, of consequence. And with that comes a question of responsibility. The politics of vision is no longer about who owns the data, but what we choose to do with it. Seeing is now a form of governance. Every Landsat image that reveals a dying coral reef, a spreading wildfire, or a flood swallowing farmland becomes a call to action, or a record of an action. The satellites keep watching. The evidence keeps accumulating. And while politicians debate, the planet keeps changing. Pixel by pixel, orbit by orbit. Landsat does not take sides. It merely reflects what is. But in that reflection lies the quiet power to hold everyone accountable. Because the truth, once visible, cannot be unseen. Part 12. Signals from the future in science. Continuity is power. But in orbit, continuity is fragile. Even the most carefully engineered satellites age. Sensors degrade, circuits corrode, orbits drift. The same applies to the civilizations that build them. Programs rise and fall with budgets and political will. And yet, against all odds, Landsat has endured, evolving through generations of technology, carrying humanity's gaze into the future. The story didn't end with Landsat 8. In September 2021, under a sky streaked with autumn light, Landsat 9 thundered upward from Vandenberg Space Force Base. The launch was quieter this time. No Cold War urgency, no frantic race for dominance, but its meaning was profound. For the first time, the program had achieved something like permanence. 50 years after the first satellite lifted off, the Landsat legacy continued unbroken. Landsat 9 was built as a near twin to its predecessor, carrying two upgraded instruments, the Operational Land Imager 2, OLI-2, and the Thermal Infrared Sensor 2, TIRS-2, designed to provide sharper, more stable data. Its orbit was synchronized with Landsat 8, so that together they could image the entire Earth every 8 days, doubling the program's efficiency. The launch symbolized more than technological endurance. It was a statement of intent. Humanity was not content merely to record its past. It was committing to observe its future. With Landsat 9 in orbit, NASA and the U.S. Geological Survey began planning the next generation, Landsat Next, scheduled for the late 2020s. This mission would triple the number of spectral bands, increase spatial resolution, and revisit each point on Earth every 6 days. Its purpose was not just observation, but prediction. The data would feed into climate models, disaster response systems, and agricultural forecasting networks, all driven by artificial intelligence. In effect, Landsat Next would become part of a planetary nervous system, sensing and responding to change almost as it happened. For scientists, it represented a long-awaited convergence. Decades of human observation merged with the analytical power of machines. For the first time, we would not only see the world changing, we would understand why and how to respond before it was too late. Yet, even as technology advanced, the spirit of Landsat remained the same. Its mission was still guided by a simple, enduring idea to keep watching. There's something almost poetic about that persistence. Each satellite, though built of metal and code, carries a trace of the human desire to know, to measure, to remember, to care. The engineers who designed Landsat 1 in the 1960s could never have imagined that their creation would still be orbiting in concept half a century later. They were building for a moment. What they created was a legacy. And that legacy is now being woven into the digital future. Today, every new Landsat image is automatically uploaded to cloud databases, accessible to anyone, anywhere. A farmer in Kenya, a teacher in Iceland, or a policymaker in Peru can examine the same pixels that scientists at NASA study. The gap between space and Earth has never been smaller. In a way, the satellites have made us more present than ever before, forcing humanity to look at itself in real time. But this new awareness also carries an unsettling undertone. As Landsat's successors become ever more precise, the planet's transformations are rendered with painful clarity. The drying of wetlands, the spread of wildfires, the bleaching of reefs, all unfolding before our eyes, impossible to ignore. The signals from the future are already here. They appear in spectral bands, in data maps, in the subtle flicker of pixels that mark a river running lower than it did last year. They whisper through climate models and sea level projections. They tell us, in quiet, empirical language, what kind of world we are building. And if we listen, they offer more than warning, they offer guidance. Because within those signals lies a paradox. The same technology that documents our damage also contains the blueprint for repair. The same satellites that reveal deforestation can help design reforestation. The same sensors that track drought can optimize water use. The same data that measures crisis can model resilience. That, perhaps, is the true genius of the Landsat vision, not simply to look, but to learn. Half a century after its beginning, the program stands as a bridge between what humanity was and what it might yet become. A continuous thread of light connecting generations, orbit to orbit, eye to eye. The future, it turns out, isn't arriving suddenly. It's been circling us all along. And as long as those satellites continue to pass overhead silent, steady, impartial, we will keep receiving the same message again and again. Keep watching. Keep learning, keep remembering, because in the reflection of that distant lens, we may still find the path home. Part 13. The turning sky. Every 99 minutes, Landsat 9 completes a journey around the planet. A path so precise that it crosses the same regions at nearly the same local time, tracing a continuous spiral of light and memory. To those who work with its data, this orbit feels almost sacred. A mechanical ritual that binds technology, Earth, and time together in quiet synchrony. Below, continents turn beneath the satellite's gaze. The Sahara blazes gold. The Andes cast shadows hundreds of kilometers long. The Pacific gleams like liquid glass. Each frame it captures freezes a fraction of the planet's rotation. One heartbeat in the endless rhythm of the turning sky. To most people on Earth, this motion is invisible. We go about our lives under the same atmosphere the satellites glide above, unaware that our every field, forest, and city is part of a vast mosaic being stitched together from space. Yet somewhere, in a data center, that mosaic grows, image after image, orbit after orbit, documenting not only the world's surface, but its story. And the story is accelerating. The turning sky no longer reveals slow, geological change alone. It reveals the pulse of a species that has become planetary in its reach. One orbit shows new farmland carved into Amazonian forest. The next reveals fresh urban sprawl spreading across Nigeria's coast. Elsewhere, an unexpected green patch appears where a restoration project has begun to heal the desert. The sky watches all of it. It neither condemns nor forgives. It simply records. Scientists sometimes speak of a temporal baseline, the record against which all future observations are compared. Landsat's baseline now spans more than 5 decades, allowing researchers to measure not just cycles of nature, but the trajectory of civilization itself. The satellite doesn't merely show what has changed, it reveals how fast we are changing, and that pace is staggering. Forest loss in the tropics has doubled in some regions since the 1990s. Coastal cities have expanded by more than 40% globally. In Greenland and Antarctica, glaciers are receding faster than any model from the 1980s predicted. To see these shifts layered atop one another is to glimpse not only the beauty of evolution, but the peril of acceleration. The data is unambiguous. We are living through a planetary transformation visible even from space. But Landsat also shows something else, something quieter, harder to quantify. It reveals adaptation, terraces reappearing on eroded hillsides, reforestation zones taking root in abandoned mines, solar farms glinting across once barren plains, wind turbines turning like silver seeds in the desert wind. Humanity, though reckless, is learning. The orbiting lens captures both sides of the equation, destruction and renewal, each circling the other like light and shadow. And as the satellites trace their silent paths through the upper atmosphere, they bear witness to a paradox as old as humanity. Our capacity for damage is matched only by our capacity for creation. Sometimes, late at night in control rooms at NASA and the USGS, engineers watch the live telemetry scroll across their monitors, numbers representing voltages, temperatures, orbital speeds. It looks sterile, mathematical, yet every data point is a fragment of something vast and emotional, the living portrait of a planet still fighting to balance itself. In these moments, the technicians know what few others can feel so directly, that our world is both ancient and immediate, immense and intimate. That to see Earth from space is to understand that everything we have ever known exists within a single thin film of air and light. When astronauts aboard the International Space Station look down at night, they see the same view Landsat captures in daylight, the delicate curve of atmosphere glowing faint blue at the edge of darkness. They describe a feeling, awe, fragility, unity, that they can never quite explain once they return to the ground. Landsat, though unfeeling, transmits that same message with every orbit. Each pass says, "This is home." Each pixel says, "You are part of this." Each year says, "Remember." In the turning sky, there are no borders, no divisions, no separate destinies, only a shared world, luminous and finite, drifting through space. As the satellites glide through their eternal sunrise, they remind us that seeing the Earth is not just a scientific act. It is an act of reverence, because every image they capture, every byte of data they send, is ultimately a reflection of us. Our choices, our fears, our hopes, written in the language of light. And in that light, the planet continues to turn. Steady, beautiful, wounded, alive. Part 14. The silent witness. There is no sound in orbit. Only the hum of machinery, the faint vibration of solar panels adjusting to the sun. Yet from that silence, the satellites speak volumes. For half a century, the Landsat program has served as Earth's silent witness, observing, recording, remembering. It never intervenes, never judges. It does what humans rarely manage to do. It watches with patience. And in that patience lies truth. Every revolution around the planet adds another layer to a record unlike any other. It is not written in ink or stone, but in light, reflected sunlight, filtered through atmosphere, captured by sensors, and translated into streams of numbers. Millions upon millions of coordinates that together describe the surface of the world. From those numbers, scientists reconstruct the living planet, the rise and fall of vegetation, the shifting lines of rivers, the advance of sand dunes, the birth and death of lakes. The data is precise, but the story it tells is emotional. Because what Landsat reveals, above all, is the passage of time and the mark we leave upon it. The satellite sees things no one else does. It has watched glaciers calve and crumble into the sea. It has seen forests reduced to ash, then slowly, stubbornly reborn. It has traced hurricanes spiraling across oceans, their cores glowing with thermal heat. It has watched volcanoes awaken, floods recede, and deserts bloom after unexpected rains. From its vantage point, every catastrophe and every miracle occupy the same frame, and still it watches. The Landsat engineers like to say that the satellites never sleep. Even during eclipses, when the Earth's shadow swallows their orbit, the instruments wait in darkness, conserving power until sunlight returns. It's a kind of mechanical meditation, a pause between breaths. Then, as the solar panels light up again, the witness resumes its vigil. Each pixel captured is a memory, and each memory carries both evidence and emotion. When researchers line up decades of Landsat imagery, thousands of frames layered like translucent pages, a strange beauty emerges. Time itself takes form. Forests pulse with growth and loss. Rivers writhe like living veins. Cities flicker outward in geometric bursts. It is as if the Earth were drawing its own autobiography, using light as ink and orbit as pen. But there is another layer to this witnessing, a moral one, because to witness is also to remember on behalf of others. Landsat doesn't forget the disasters that fade from news headlines. The data preserves them long after public attention moves on. The flood plains of Pakistan in 2010, the wildfires of Australia in 2019, the smoke that blackened California skies in 2020. All remain archived and accessible so that future generations can study, understand, and perhaps prevent what came before. In this way, the satellite becomes a custodian of memory, not just for scientists, but for all of humanity. There is an image taken by Landsat 8 in 2015 of a region in Siberia where melting permafrost has carved deep scars into the tundra. The photograph looks almost abstract, ribbons of blue and green twisting across pale soil. Yet beneath its beauty lies a quiet alarm, the ground itself collapsing as ancient ice releases its stored carbon into the air. It's not just a landscape, it's a message written in the language of climate. Every frame in the Landsat archive carries messages like this, warnings in color, waiting to be read. And still, through every orbit, the witness remains silent. It does not urge or plead. It simply continues to collect evidence, trusting that somewhere, someone will listen. Perhaps that is the quiet power of Landsat. It teaches responsibility not through fear, but through awareness. It forces us to confront the truth that knowledge alone is not salvation, but it is a beginning. We often imagine the satellites as distant mechanical watchers. But in truth, they are mirrors reflecting not only the planet but the civilization that sent them. Their silence is not emptiness. It is invitation. An invitation to look, to think, to remember. In that silence, we are reminded of what is at stake. Because when the satellites finally fall silent, when their instruments fade, and the last signal returns to Earth, the question will remain, did we learn from what they showed us? Until then, the witness endures. High above the noise of politics, borders, and denial, it circles endlessly, capturing the light of a world still capable of wonder and of change. Part 15, the last transmission. There will come a day when the signal fades. It might happen suddenly. A power surge, a software glitch, a micrometeorite strike, or quietly, as components age and sunlight no longer sustains the batteries. Every satellite eventually reaches that moment. Even the most enduring machines cannot orbit forever. When that day arrives for Landsat 9, and one day there will be a final image, a final transmission. A last pulse of data crossing the void between space and Earth. It will arrive at a ground station, maybe in South Dakota or Alaska, as a stream of numbers no different from the billions before it. But for those who understand what it represents, that final downlink will feel like the closing of a long, beautiful chapter. Because in truth, every Landsat mission is a message to the future. From the first grainy photograph of 1972 to the high-resolution mosaics of today, each satellite has sent a simple, enduring statement. We were here. We watched. We cared enough to keep looking. The Landsat archive, millions of images spanning half a century, is now one of humanity's most complete self-portraits. It doesn't show our faces or our cities directly, but something deeper, the imprint of our existence on the living world. It records the slow choreography of forests and oceans, the geometry of civilization spreading across the land, the scars and recoveries of a restless species. When future generations, or perhaps beings we can't yet imagine, examine that archive, they'll find more than data. They'll find testimony. They'll see how glaciers vanished and deserts grew, how rivers wandered, deltas fractured, and islands drowned. They'll see how we mined mountains, drained lakes, and then, in some places, tried to heal what we had broken. They'll see the paradox of a species powerful enough to reshape the planet, yet vulnerable enough to depend entirely on its stability. And they'll see that through it all, we never stopped looking. That's what gives the Landsat story its quiet grandeur. It is not just about satellites and sensors, but about continuity of care, the decision, renewed generation after generation, to keep watching the Earth no matter what else changes. Each new satellite carries not only instruments, but intention, a promise passed from one era to the next. The engineers who launched Landsat 1 in the 1970s could not have known that their work would outlast them, that their technology would become the foundation of global environmental science. Yet their vision, to give the Earth a mirror, proved stronger than the decades that followed. Now, as Landsat 9 circles the planet and Landsat Next waits in the wings, that vision endures. Humanity has built a chain of observation that spans lifetimes, cultures, and continents. An unbroken thread of light connecting every generation that dares to ask, what is happening to our home? Perhaps that is what the last transmission will truly mean. Not an ending, but a handoff. A signal passed to whoever comes next, saying, the story is not finished. Keep watching, keep listening, and maybe somewhere in the future, another satellite more advanced, more sensitive, will look down and see not only scars, but healing. Forests returning, oceans recovering, cities glowing with clean energy, the evidence of a civilization that finally learned to see and to act as one. When that day comes, the Landsat archive will be the proof of how far we've traveled, from blindness to awareness, from separation to connection. For now, the satellites continue their endless circuit, silent and steady, gliding through darkness into dawn. Below them, the planet turns, blue, luminous, fragile, alive, and high above, in that thin edge of sunlight where space meets sky, a small machine keeps sending its signal home. Still here, still watching. Epilogue, the light that remains in the end. Perhaps Landsat's greatest legacy is not the images themselves, but the change they create within us. To see the Earth as it is, whole, finite, astonishing, is to feel both responsibility and reverence. The light that left our world 50 years ago continues to circle it today, bouncing between satellites and servers, between science and imagination. It reminds us that observation is an act of care, that memory is a form of preservation, and that seeing clearly is the first step toward hope. So as long as those eyes remain above, silent, unblinking, faithful, the Earth will never truly be alone. For in every orbit, in every image, in every glimmer of reflected sunlight, one message endures. Look closer. This is your home.